Thank you. So, as I said, Ron Cates, and we're going to start here. You like the big black blob? I call that the deal. Thanks for having me. I feel kind of like, next month we're going to have the presidential turkey show up at the White House. I kind of feel like that presidential turkey, and I need a pardon. All right? Because several of the people in the workshop said, you are the source of this problem. So, okay, let's go with that for now. If I really believe that, I don't think I would be here. It'd be a good guess, right? So we're going to talk about if semiconductor suppliers understood the impact, would they still EOL components? That's the topic of our deal. So there's a few ground rules. I usually work with the sales team. All right, and I was hoping today to really get a big benefit out of this because we only have 20 minutes. We're going to focus. Here's a few things. There's a $20 fine if your phone rings. It's $100 if you actually answer it. Okay? Now, you're probably thinking right about now, okay, where does the money go? The money goes to a really good cause. I've worked on it my whole life, the RLC Retirement Fund. So that's where it goes. I'm going to show you a lot of public data, and all the references are cited. They're all in the thing. You get a copy. Don't try to look at all the data and whatever, because you can study the data after the session. The content is available. Everything is public. I didn't pay for anything. Okay? Now, you're going to say the data looks a little older. It's still valid. If you'd like to buy the data, feel free. It's rather expensive. Oh.
That was me. $100.
All right. Sweet. I was worried about that. Growth today is all memory and flash. If you say the industry is growing faster, there's a little bit of data around, but most of that is in flash and DRAM. And what is driving that are these things. 256 gigabytes of flash in one unit. All right, that's a lot. That and solid state disk drives. My email is on the last slide. If you have a question, feel free to ask. All right, with that, we'll get going here. On my first job, I got out of college, I worked on the F-16. I've been around for a while, so I have a little bit of experience in the military domain. It was the first fly-by-wire aircraft. What did I learn out of that is pilots don't like beta software. You don't say, hey, let's put all the software on here, go out there, Mach 2, let's see what happens. They don't like that, all right? We had a whole bunch of testing we had to do. Engineers and purchasing have goal conflicts. As a rookie engineer at General Dynamics, they say, we hate purchasing, you go talk to them. So you're only waiting until they hire somebody else so you don't have to go talk to them, okay? When you do something that's never been done, it's hard to determine exactly how long it will take and how much it will cost. So we're doing a fly-by-wire airplane. Well, how long is it going to take? How much is it going to cost? How long is it going to take? How much is it going to cost? It's never been done before. Right? People in this industry, there's a big challenge in this area. We're trying to do things that haven't been done, but I got to tell you everything and hit it. It's a bit of a challenge. So why are we here? That's our setup. We're here for one big reason, which is the life cycle of integrated circuits is going down. Now, the sources on here, by the way, if you get the file, you click on it, it's linked, it'll go out to the web, you can look at the data. This is extremely difficult data to generate. As a matter of fact, I can't generate this on my internal systems myself for my product line. My systems are geared toward timestamping changes, not initial releases. So when we implemented a TS flow, all of the dates were used for change control. So it's very difficult to get this data, but it is going down. So what is driving this obsolescence? If I show you a thing out of the Defense Manufacturing Guide, it says in here, technical obsolescence drives it, and it's driven by the production rate for existing facilities, right? And that was probably true at one time. I'll warn you that may have changed, all right? That was probably true at one time, but it may have changed. So if you look at the semiconductor market, another source here, interesting curve, isn't it? Really high growth rate up until about 1996, then it flattens out. If you look at 1996, that was when mobile phones, network infrastructure, and PCs hit a 90% adoption rate in the developed world. And when a market gets 90% adoption, it goes into replacement mode, not growth mode. So this is up here. So things that were going on back here are different than things that are going on here. So what drove the obsolescence in the growth phase, in that first phase of 20% per year growth? You have to realize, when I first came in here, up 5 was a recession. If you were flat, we had one of those, oh my God, we'll have to all go out of business. So when you have revenue growing 20% per year, anybody in here have a company that's revenue is growing 20% per year? It's tough. Revenue growth funded capacity. I need to add capacity because I'm getting new money, I'm getting new revenue, I'm getting growth in this area. So I'm getting extra money and revenue. I'm not as focused on profits as I should be, probably. If you look at Amazon, it's growing their revenue rapidly, not the profit so much, although they're starting to get to that level. So in these kind of phases, you're focused on growing the revenue. Manufacturing capacity obsolescence was the issue, right? And why was that? Because old factories were replaced by newer and larger factories. I needed the capacity, I had the revenue, I had the money, things were happening. So basically, yes, old factories get replaced by new ones. So when it said it was driven by the obsolescence of a factory, that's a true statement. It was easier to close a facility than convert components or customers. This deadly change control. So what happened was all my old factories were full of people that didn't want to change. I say basically what happened is the customers with change control suffered the obsolescence cost. It was easier to just say, we'll just EOL it because you don't want to change. I don't want to debate it with you. The factory is unprofitable, needs to close. We'll just do it. That happened. Okay? So in this phase, that book, that guide out of the defense manufacturing was exactly correct. It was exactly correct because we were building bigger factories, newer ones, and whatever to run. Now, how has semiconductor investment changed? Because this is the key to why things are changing in this industry. Now, the charts are too small for you to read for a reason, because I don't want you to focus on those. So what we're going to do is we'll make them bigger so I can show you that right here, the average cost of a 10 nanometer fab is $12 billion. $12 billion. That is not going to get applied to a 10-cent component. Okay? The average cost of developing the 10 nanometer process to run in that fab is $2.5 billion. Pretty pricey. And then the average cost to develop a 10 nanometer chip is $400 million. So that first chip in 10 nanometer is a little pricey, for almost $15 billion. So investments are larger, assets are going to last longer, and I think technical obsolescence will slow down. It's not going to be the obsolescence of the factory that drives this because the investment's so high, you're going to run that thing till it falls apart. Right? I mean, we say we have declining infrastructure in the country. Why? Because it hasn't fallen down yet. We'll keep doing it because we don't have money to replace it. So, that larger investment in technology, everybody knows Moore's Law says that you shrink it and it gets cheaper, right? Well, it works really well until you get down to 28 nanometer. And something happened right here where the cost went up. The actual cost of the silicon went up. Now, it stayed up. I think it comes back down at 10 nanometer. It's just a little bit more expensive than 28. At 7, it might be cheaper. This is caused by, for all the engineers in the room, using 193 nanometer light with 20 nanometer mask openings. So the light comes down, and basically that small mask looks like it's solid. It just reflects the light back. So what we have to do is actually, it's called immersion lithography, where we put water. And the water helps the light go through and focus it. But what gets down there is you start having to double pattern and triple pattern things, and it's slowing the things down. So basically, any skeptics? Some people say, oh, everybody knows Moore's Law is cheaper. Where did that come from? Well, here's another data source. Same inflection point at 28 nanometer, but it's different data. I don't care about the data, but I do care about the inflection point, because I need to understand that difference in order to do it. So once again, different data point, different site, but focus on 28 nanometer, because that's where immersion lithography starts, and that's where double and triple patterning starts on the wafers. And what that means is, if I make the wafer bigger, since I have to put it 2 or 3 times to pattern it, it's not scaling. If I make the wafer bigger, it just takes longer. So the equipment costs more, takes more process steps, so the product slows down. I don't get any output. So this is the challenge in this industry, if you've heard this. So will that continue? Here is an article that came from Global Foundry, says it suspends work on 7 nanometer technology. So it basically says the strategy to invest in current technology that could remain in use for years and matters more to its customers. For many of you people, it says leaves Intel, Samsung, and Taiwan Semiconductor to fight over the most advanced. So what's happening down here is the investments are so high. I saw some comments, I'll throw in a few things, about multi-source. If the investment is $500 million, there's not going to be 2 sources, because no market is big enough to absorb $800 million development cost. Just not going to happen. It's just basically, we're going to do this. The industry dynamic is fewer fabless clients are designing. The cost to design the chip is so high that not too many semiconductor companies can afford the $400 million development cost of the chip. All right, it's that simple. So if you're still skeptical on that, you say, well, that was one guy. Foundry challenges here. Many foundry customers stick with 28 nanometer. If you leave with one thing, 28 nanometer is sort of the inflection point in there. And by the way, from Microchip, we don't have a lot down there. We're more up in the other end because it's just too expensive for what we do. So the risk of technical obsolescence in the future, if you leave here, I'm going to say probably that's not the problem anymore. For people that we're talking about, well, sometimes we get it designed in, we're ready to go, and it's already EOL. You're worried about this part of the technical risk on the front end. I'll warn you, if a design and a process is only going to last for 18 months, which was what Moore's Law was doing, is there any technical risk in the front of an 18-month total cycle? When you hit it in production, it better be running, because you're not going to ship it that long, right? So it's a mature industry. We've gotten very good at actually minimizing this problem. So I would tell you one of your solutions is not to worry about that so much, at least in the higher end of part of the semiconductor market. So we got back and we're saying, okay, technology is slowing down, it's more expensive. However, we have this little issue that is still going down. What's causing this? Because this is what we need to understand. So in a mature market, whenever that thing rolls over, the problems you get to is obsolescence shifts to the component level, not the factory level. I'm obsoleting that component, not the factory that builds the component, right? It's a little bit different. And the reason we do that is because it's unprofitable. The number one reason today in this market is because your components aren't making any money. And if you're not making any money, you have a problem in this industry. Profits are funding the capacity expansion. I don't have revenue growth. I have to fund this out of profits. It's a little bit different dynamic. So what is causing that? Well, your purchasing department. Everybody know what PPV is? Right? Here's some statements that come from your purchasing departments to my sales team. Our supply partners reduce costs and share cost reduction with us. I got news for you. We don't have a cost-based relationship. We have a money-based relationship. Here, I got a whole handful of cost reduction. You want to share? That didn't work out too well, did it? So, can't do that. We limit our supplier profitability to your cost to 10%, whatever. All those are nice statements. This is the one I particularly love, and it may have come from somebody's purchasing department that's in this room. You need to learn to lose money like the other suppliers. This is what my sales team deals with on a daily basis. You should just be losing. I had one guy a company tell me, I worked with them for a long time, that says, you get to work with this company. It's very prestigious, happens to be a Dow Jones 30 company. You're so lucky that we shouldn't have to pay for the material we buy from your company. It's such an honor. And I said, well, it is for me personally, but I don't think my shareholders are going to agree. This is a written purchasing strategy statement. Comes from a written down purchasing strategy. This is a statement. Be prepared indirectly and under pressure to bluff and lie. A written down business strategy with the word lie. Right? This is automotive, by the way. This Lopez guy who worked at General Motors. If you click here, it will take you to the document C6F. I didn't make that up. It's there. So how would your factory respond? Here's a little bit of data. It's too small, isn't it? Okay, the things that I want you to remember are simply, in 2014, we have this data, about $16 billion, 19 billion units. In 2019, the forecast is 21 billion and 49 billion units, which is basically a 6% revenue growth and a 21% increase annually in units. All right? Could your factory do that? It'd be tough. I guarantee it'd be tough. So, this is my test floor, and this is in Thailand. This is what testers look like, And you have to make them small because you have to buy a lot of them. Last time I knew we were at 900 test platforms. Financial strength is important because equipment has to build the units. This is the dilemma. This is what's driving consolidation in this industry. If you understand one number on this chart, you will understand what's driving consolidation. Profits by the equipment, I need 20% more units, but I only got 6% more revenue to do it. Problem. Total cost is growing faster than revenue. Right? Basically, it's not quite this simple. Revenue is growing here, and my total cost is growing here, which means my profit margin is eroding. It's not quite that simple. I don't want to get into accounting with everybody. I don't even like to get into accounting with my own people. But asset intensity is changing. How much fixed cost do you have to have in the industry? The fabless semiconductor suppliers, so fabs were expensive, so we got rid of that. Assembly testless suppliers, all of a sudden we said we can't afford to buy testers and assembly, so we'll get rid of that. We have a thing now called client-owned tooling, COT, not COTS, COT. Client-owned tooling means I don't have any money to invest in new capacity for you, so if you want that many units, you buy the equipment and I'll run it for you. Now, I know this term is a little risky here in Washington, D.C. You might not know what it means, but that's pay to play. All right? Basically, I got to pay to get more capacity. You're used to saying, I'll up my volume forecast to get a lower price. This is upping my volume forecast to get a higher price. I'll warn you, within the next 10 years, that will happen in this industry. So you ever wonder why your discrete component guys, I heard this a couple of times, those discrete guys, they shoot out there. And your purchasing has commoditized them nicely. They don't have any capital to expand, so your lead time is your only variable. I'm not going to buy any more equipment. It's queued up. It's full for the next 2 years. You put me an order in, it's going out there. It's queue time and build time. And lead time is a function of both. Most people, I'm not working on it for 52 weeks. It takes that long to get there. So the capital in this industry, from IC Insights, Semi CapEx forecast $100 billion in 2018. The actual revenue is estimated at $469 billion. So the actual capital requirements is north of 20%. North of 20%. That's to grow revenue 6%. Now, it's not linear. The Intels and those guys in the fab, the rest of us aren't. There's limited capital expansion for financially weak suppliers. I would tell you, if you want to predict obsolescence, a better thing than looking at all this data is to run a Z-score. Everybody know what a Z-score is? It's a credit score. Run a Z-score on your suppliers and find out the weak guys are probably the ones that are going to cause you obsolescence. They're probably the ones that are going to cause you lead times. They're probably the problems. Okay? So, Microchip, how do we view obsolescence? I'm not going to go through this. It's on our website. You click on this, it'll take you to the web. A little bit of interesting data here. It says purchasing organizations spend up to 60% of their time managing supply. R&D teams spend up to 30% of their resources. Finance says they got 10% of their money tied up in these things. This is a big problem, right? It is, and we try to avoid it. We use functional integration. Our products look a little bit different, and the customer delivers their innovation with software on standard hardware. This is basically an embedded system PC model, right? The software does most of the work. The hardware is pretty generic. We have 125,000 customers, so we spread it across quite a few. We have 111 straight quarters of profitability. So it is a financially strong company. Almost done. My first project in 1993 was a PIC 16C54A. And I'll warn you, it is marked not recommended for new designs. We have better technology, not like we're really old, we're stodgy and whatever. It's around. So why am I bringing this up? Well, I'm bringing it up because that 25-year-old part is available shipped from stock from my website today. Shipped from stock, my website today. If you want to talk about it after this thing, I'll be happy to talk to you. We specialize in the embedded markets, and those are slower moving anyway. Now, the B52 thing is a really extreme example. So, to leave you an idea on what you might be able to do, this is an article that says if your company does cost reductions, it's already too late. So, a lot of companies come in and basically they say, oh, we'll get it into production and then we'll cost reduce later. There's another one here called cost avoidance. Can you avoid some cost ahead of time so that you plan for it? And this is what you need to do, I think, in your thing. You want a goal alignment with your suppliers. If you want a long product life cycle, you need to find suppliers with long asset life. I'll warn you, that's not Intel. That's not Micron. All right? I don't know how to fix those problems. Those are different problems. They need to be profitable and financially strong suppliers. By the way, that probably means they're not the lowest price. Because rarely is the lowest price supplier the lowest cost for you long term. Right? I have that thing all the time. Okay, it might be the lowest price, but is it truly the lowest cost? If obsolescence cost is a big issue for you, that could be very true. Goal alignment means obsolescence cost avoidance. How do we avoid this cost? And if you can't quantify it, then I can't help you. All right, I don't know how to quantify it for you, but whatever. So with that, we're a little bit over, but the end, Microchip is designed to be better. To be better, you have to be different. So look for people that say they're different. Product longevity is a barrier to innovation. We remove that barrier so you can focus on delivering innovation. I thank you for your time and attendance today. I'll be around if you have questions. Thank you very much.
Ron Cates. Hold on a second. Let's do a little bit of Q&A. I'm sure we're going to have some fun here. Let's see some hands shooting up.
I don't know. Oh, sorry.
You're very compliant.
Nothing?
No questions for Ron. They want to get him one-on-one in the closet. That's what it is. We'll protect you. We'll get the bodyguards outside.
I'm trying to avoid the problem. By the way, as an aside, I hope you realize, none of the semiconductor guys manufacture every piece that goes into their system as well. If you wanted to avoid something, avoid PDIP packaging and PLCC packaging, because those are the two on the bubble where the supply base is going down. There's only one person for PLCC packaging left in the world. We're probably 80% of the capacity in there. We still build it. But sooner or later, he calls me up and says, hey, the new molds are going to cost $2 million. Are you going to pay for that? Otherwise, we're going to stop building it. So whatever. But if you avoid those two issues, we build PDIP packages ourselves, but we buy the lead frames, and that guy could go out of business at any time. And they don't call you up and say, oh, by the way, we're going bankrupt in a year. You know, usually they just say, hey, we're out of here. Right? So it happens to us. We will build it if you need it, and it's possible. We do obsolete some parts. It's not perfect.
I got one right over here.
Uh-oh.
Yeah, hi, Ron. Really appreciate the presentation. Very dynamic and matter of fact. So understand the Microchip history, but lately, over a couple of years, Microchip has bought a few companies, like Atmel, Microsemi. Does that change some of this, what you've been telling us today?
That's a good question. What we try to do when we acquire a company, we've bought 17 companies in the last 9 years. Right? So we've seen every bad story in the supply chain you can find. What every one of these companies has in common is they have the savior product. This product's going to save the company, and it really should have never been launched into manufacturing. Or they have a whole bunch of old stuff, but we need the revenue or whatever, and they're losing money on it. So we will try to get rid of those in the transition period. But once they're absorbed and comes into the company, then it kind of goes by the same rules. But you find all kinds. Now we actually go in there. What was the sacred chip that was going to save the company? Oh, it was that one. Okay, let's go look. And Atmel had them. We haven't found any Microsemi yet, but that only started in May, end of May.
I have a question over here.
So,
So Ron, good presentation, dynamic, of course. So did I hear you correctly? You said that the newer generation has got a obsolescence maybe a couple of years, 18 months, 2 years, in the same vicinity. I'm not nitpicking on.
that was Moore's Law, and that was about every 18 months. So if you were in that lithography curve, yeah.
So, I just heard you say that we bought Microsemi, we bought some other companies, and one of the strategies is to stop selling obsolete parts that are not making you money.
Mm-hmm.
But then I earlier heard you say, it says your first project, what, 1994, 1984, and the parts still around.
93. Mm-hmm.
So, isn't that contradictory, though?
Well, that's Microchip versus an acquired company.
But still, it's Microchip. I mean...
And that's why we try to do it in the transition when it's still, if we're going to go forward, it's going to be under the same rules. There may be some things that we can't continue. We had, one of the companies we bought was on homemade test technology. I'm sure you've seen some of that. And we said, this is not manufacturable, this is not production worthy. It was going into cars on top of everything else. And we said, we're not doing that. We'll end of life that because it's not what we want to offer in warranty. In the transition, we will tell you what's going to happen. But once we get by that, then it goes under the same rules.
One last question. So what do you think about enabling aftermarket manufacturers with your know-how?
Well, we don't do it enough to really have any experience. I've been at Microchip for 25 years, 2 weeks ago, September 27th. I have personally end-of-lifed 3 products. And we had pin compatible. 2 of them were ROMs where we had a flash or an OTP equivalent. So there was nothing changing. Another one, we didn't have any customers on it anyway, it didn't matter. But the problem you get into, and just in general, so not Microchip, but in general, the issue is going to be, I have a product that's losing money and you want me to spend engineering resource to transfer the technology to somebody else. That's a difficult pill to swallow from a financial standpoint, right? And then number 2 is we have a whole bunch of built-in test stuff. If you can get into a PIC micro, good luck. Because we have all kinds of built-in test things. Every pin's bidirectional except power and ground. I don't know if you go look at the layout and you can figure that out, but we have all kinds of built-in stuff. I'm basically have an 8-pin part that's sending a 24-bit instruction into it. So it has all kinds of built-in test stuff to really test it. Yes, sir?
So what about licensing your IP that you don't want anymore?
Hold on a second. I'll repeat that. What about licensing the IP?
Yeah.
What kind of IP? You mean PIC micro or?
So you have a chip you're not going to make anymore, right? You have the lithography, the mask.
We don't have a lot of experience in end-of-lifing, so we haven't had that come up.
Would that be something that you would?
I doubt it. I really doubt it, just from a standpoint of, unless I'm obsoleting an entire product line, which we would be, I don't know how to do that in whatever, I doubt it. There's always unique cases, but I'm going to say for the bulk of our IP, the answer is probably not.
Okay, that'll do it for Ron Cates. Give it up.
All right.